Hey there, welcome. Our first question is how many milliliters of D5W can be made from 1,000 milliliters of D 21% and still water for injection? You're here at Excellence Pharmacy Tech Training. Here we go. Hold on. Just wait a minute. Some of us, when we look at problems, we go and we try to go to our happy place because we're saying, this is not happening right now. I'm not being asked this type of question right now because I don't know how to do it. I don't remember how to do it. I don't want to do it. Whatever your situation is, know that you are not in Shangri-La. So don't go to Shangri-La just yet. Wait till you solve the problem. Have no worries because I'm going to show you how to tackle this monster in a minute. I've taught a lot of students and I've seen a lot of things. And one thing that I know is people look at this type of question, or any question for that matter, and they take the question in its entirety all together. And that is not bad, but it's incomplete. What do I mean? I mean that you have to have the ability to look at the question as a whole, yes, but then you have to be able to break it down into its elemental parts. And that's where people miss the mark. You see, first of all, if I asked you what type of question this is, what would you tell me? And I can put some time on the clock, maybe 30 seconds, and just let you think about what type of question this is. Okay, that was 10 seconds. 30 seconds is a long time. Well, I'm going to tell you, since this is the first question in the series, this is a dilution type problem. It is a dilution type problem. How do you know it's a dilution type problem? Is because you have to look at this in time, in sequence, the sequence of time. So in the beginning, you're going to have a container of D 21%, which is dextrose 21%, and you have a whole entire liter of that, right? And in another container, you have sterile water for injection, right? Now, you have to take the right amount of D 21% and sterile water to make an unknown amount of D5W. I'm going to say that again because it's important. You're taking an entire liter of D 21%, which we said is dextrose, 21%. It's diluted in sterile water in that container. And then in a separate container, you have sterile water and nothing else. Okay? You have to combine those two things so that the concentration is 5% of dextrose. The question is, how many milliliters of dextrose 5% can you make from what you have? I tell students all the time that you have what you need. You have what you need. Now, let me let that sit for a minute. You have everything you need. Everything you need is right there. You have it already. Now, I will tell you that there are two ways to solve this problem. Okay, so the two ways to solve this problem are as follows. First, there is something called quantity times strength. The quantity of the first solution times the strength of the first solution equals the quantity of the second solution times the strength of the second solution. Okay? That is one method, quantity times strength. Then there is a separate method for those that are a little bit more advanced called alligation. Now notice the spelling of allegation here is A-L-L-I, not A-L-L-E. A-L-L-E is an accusation. A-L-L-I-G-A-T-I-O-N is a mathematical matrix. And we're going to talk about the allegation in a subsequent video. The reason being is that there's certain criteria that has to be met for whatever method you choose, right? For quantity times strength, you have to have a solution that you're diluting, okay? And for the allegation method, I have 3 questions that you have to answer. The first 2 questions tell you that it is an allegation. So if it's yes to the first 2 questions, that is an allegation type problem. Whether it's yes or no to the third question, that tells you what type of allegation it is. So I'm just introducing it right now. So very briefly, for the allegation method, the question is, the first question is rather, do I have 2 strengths of the same thing? Do I have 2 strengths of the same thing? And I'm being asked to make a third. That is the first question. Do I have 2 strengths of the same ingredients? And I'm being asked to make a third strength. The second question for the allegation method is, does that third strength numerically lie between the other 2? Okay? And the third question for the allegation is, do I know what my final amount is? So when all is said and done, do I know how much I'm going to end up with? Like I said, I'm just introducing the allegation method because in order for me to teach that to you, you really have to have a handle on the fundamentals. And we're not truly there yet. So I don't want to give you too much too soon. Okay, but just know that with this type of problem, there are 2 ways to solve it. Today, we're going to talk about quantity times strength. So hold on, we're getting there. It's important that you get a clear mental picture of what is going on. So you see that the sterile water for injection does nothing else but dilute. This is important that you phrase it that way, that it does nothing else but dilute, because when I show you the allegation method, that is important. That is important to know that it does nothing else but dilute. For quantity times strength, it's necessary that one of your ingredients does nothing else but dilute. But when we get to the allegation method, it's important to have that information because you're going to phrase it in a different way. Don't worry if you don't understand what I'm talking about. It's okay because I'm going to walk you through the allegation method at another time. Okay, but just know for quantity times strength that one of your ingredients has to do nothing else but dilute. With quantity times strength, you can only have two solutions that are separated by time. What do I mean by that? You have one solution, one entire solution that is present in the past, and you have one solution that is present in the future. Okay? In this case, your dextrose 21% is present in the past. Why? Because you're going to add something to it and change that strength, right? Your dextrose 5% is present in the future. You haven't made it yet. Or let's even say that you have made it, but you're looking back to see how you made it, if that makes sense. But with all word problems, you have to visualize what is going on. Okay? You have to have a vision of what is happening. If you get the wrong vision, you'll get the right answer to another problem, which happens to be the wrong answer for this one. All right? So let's keep moving on. Okay, so at this point, we're going to go to the pen and paper. So we're going to write Q1S1 equals Q2S2. The quantity of the first solution times the strength of the first solution equals the quantity of the second solution times the strength of the second solution. So I'm going to set it up. I'm going to say my solution 1 is going to be my 21%. My solution 2 is going to be my 5%. Okay, so I'm going to say 1,000 milliliters times 21% equals X, my unknown, times 5%. At this point, I need to get X by itself. So what is next to X is 5%. That relationship with 5% and X is actually one of multiplication. So I'm going to divide that whole expression, X times 5%, by whatever X is multiplied by. So it goes like this, X times 5% divided by 5%. Whatever I do on one side of my equation, I have to do on the other side of my equation. When you see the equal sign, you have to think of balance. Balance is what an equal sign is. So whatever I do to one side, I have to do to the other side. So I divide the other side by 5%. You're saying, whoa, hang on, Vanessa. What is going on here? I got percents in my equation. I didn't sign up for this. Well, it's okay because you can cancel. So on the right side, you have your 5%, right? So 5% in the numerator and 5% in the denominator. You can get rid of that 5% in the numerator and get rid of the 5% in the denominator. On the left side of the equation, you can cancel the percent signs. So the percent in the numerator gets canceled, the percent in the denominator gets canceled. All right? There's more. So you have a 5 in the denominator and you have 1,000 in the numerator. Well, 5 goes into 1,000 200 times. So you cross out, you cancel out the 5, you put a 1 there. You cancel out the 1,000, you put a 200 there. All right? So at this point, you multiply to simplify your numerator and your denominator. In this case, Your denominator is a 1, so you divide by 1, you get what you started out with, okay? So you take 200, multiply it by 21. That gives you your 4,200. 4,200 what? My only unit that's left standing is milliliters. It has to be milliliters. 4,200 milliliters of what? Well, let's go back to my question. It's of my 5% dextrose. Okay? All right. So we have completed this problem. Yay! I'm going to go Hunger Games right now. Breathe it in, children, because we're at Shangri-La. Right now, we've arrived. We have solved our problem. We have visualized what was going on. We have done the setup correctly. We have done the solving correctly. We have done these things correctly. Now we can take a breather. Breathe it in, children. So we've gotten at the point of the video. If you like what you've seen, if you like what I've covered in this video, I would say like and subscribe and catch me on the next one. This was my pleasure to go through this with you. I'm going to give you some more examples of quantity times strength, so stay tuned. And don't forget that I'm going to talk about the alligation method also at some point. And I'm going to give you a little compare and contrast. I'll probably do the same problem that I did here today by alligation. And that way you can compare and contrast and see what's necessary to perform that method. So here on this channel, we specialize in pharmacy technician math. And if you have a question that you just can't figure out and is driving you crazy, don't go crazy. Send us your question. It's possible that we may feature it in an upcoming episode. Okay? Sounds good to me. Does that sound good to you? Here's a little poem from me to you. I thank you for watching. God bless you too. And you're studying. Woohoo! We got it. And I want you to continue working out these types of problems. I'll see you on the next video. Ciao.